Welcome. In this video, I'm going to talk about one sample proportion test, which can be used for analyzing a binary variable. In a previous video, I've shown and talked about getting a frequency table to get an impression of your data. In the example we've used, we had a frequency of 12 and 34 for respectively females and males, and these were the two corresponding percentages. In this video, I'm going to demonstrate or talk about how we can determine if these two percentages are significantly different from each other. To test if those two percentages are significantly different from each other, there's a whole range of different tests that can be performed. The first big split is in an exact test, which is a one sample binomial test, for which I have a video all by itself. Another approach would be to use some kind of approximation. An approximation is usually preferred if you have a very large sample size, because then an exact test can take quite a long time to actually be performed. Now, there are some articles, like for example this one, where they're talking about an approximate is even better than exact for at least interval estimation of binomial proportions. I didn't go through all the details in the article, but so there's more to it than just the computation. But in any case, many people will recommend to use an approximation if your sample size is very large. There's one stats test, I think, was the website, recommends that if you have less than 1,000 to use an exact test and otherwise an approximation. Now, with the approximation, there are actually two different options. So we can either approximate the binomial test using a normal distribution or a chi-square distribution. Now the normal distribution, there are actually two options there as well, which is known as a score test or a wall test. The difference has to deal with how you compute your standard error. With the wall test, you use your sample proportion, while with a score test, you use your hypothesis proportion. Now for the chi-square distribution, there are also two different tests. There is a Pearson test or a g-test. The g-test is also sometimes referred to as a likelihood ratio test. And all of these are so-called goodness of fit. Because these chi-square distributions tests, they also often have a test for independence, which is a different topic in itself. So that stats test recommends to use the g-test. The g-test to some extent is less known than the Pearson one. So if you want a test that more people are familiar with, use the Pearson, although the g-test is gaining ground as well. But that's not all, because both the normal distribution and the chi-square distribution are approximations of this binomial distribution, or at least that's what we're using it here for. And the binomial distribution is a so-called exact test. So that means it actually has categories like 1, 2, or actually it starts at 0, 3, etc. Depending on how many categories you have. In this case, we only have 2, but let's say k categories. Now normal and chi-square are continuous, so 1 is actually in a continuous the same as between 0.5 and 1.5. So to adjust for this, that we're actually going from a discrete to a continuous, there are also some kind of so-called corrections for this. And that can also be done in different ways. The most popular one and often seen is the Yates continuity correction. That only works with a goodness of fit test when you only have two categories, so indeed with the binary data. And for the chi-square distribution, there is also a so-called Williams correction and a Pearson correction, and that's a different Pearson than the one from the Pearson chi-square test. One is Carl Pearson, and the other one is, I think it was Edward. So we have quite a lot of choices. The one most often used is with a Yates correction. And as mentioned earlier, so you could do a g-test with a Yates correction if you want to do an approximation. And if you have a very large sample size, then use that approximation, and otherwise perhaps just use the exact test. But those are all the different variations I've come across, and there are probably more. Now, once you've decided on the test you want to use, you probably want to find the so-called significance or the p-value of that test. Now, I have different videos on my website on SPSS or on Excel, or how to do it with R or with Python. And for each of those, I have separate videos on how actually obtain this p-value, or sometimes referred to as significance. Of course, you could also do the math manually. On the website, you'll also find all the formulas that you probably need for that. Once we have run the test, we can actually have a look at the result and interpret it. The first thing to remember was that with these tests, we assume that the two proportions are equal in the population. In other words, we assume that the percentages in the population would be 50-50, so 50% for each. The test has shown a probability of, let's say, 0.0004 of obtaining a sample as we had, or even more extreme if this assumption would have been true. Now, this is a very low chance. Usually the threshold is put at 0.05. So in this case, we therefore reject that assumption that those two proportions are equal. So since we reject that, it must mean the opposite, that they are not equal. And we call this then a significant result. So the two proportions are significantly different from the expected 50-50. If the p-value is 0.05 or higher, then we would simply say that we don't have enough evidence to reject it. We wouldn't say it's therefore true, we just say that there's not enough evidence to reject the hypothesis. This first one, to assume that the two proportions are equal, is the null hypothesis. We also need to report the results in APA style. For a normal approximation, we need to at least show the Z value. That's the Z statistic. The software usually produces that one as well, and that significance. And that significance is usually with 3 decimals, and there's no leading zero, I think it's called, so no 0 dot, just dot 034 or something. For a chi-square test, it's a little bit more. You need to fill out the degrees of freedom, which is 1, because we're only having 2 categories. Then there is the sample size, and then you fill out the chi-square value itself. That's usually also calculated by the software program that you're using, and again the p-value. It's also good to mention the test that you've used and any corrections. So for example, I could write down a 1 sample walled proportion test with Yates continuity correction indicated that the percentages of female was significantly different from that of the males, and then the Z value and the P. Now you might notice I've used P's less than 0.001, which is quite common to do if it's indeed less than 0.001. If it would have been 0.23, I would have simply used an equal sign and then listed 0.023, for example. Right, and that's how you can do those 1 proportion test. Hope you enjoyed this video, and if you have any questions, let me know in the comments below. Thank you for watching.